each one separately. The derivative would bypass the 5 because it's a constant multiple, and it would attach itself in a sense to the e to the x. The derivative of the x is e to the x, so it just comes back, and the 5 just stays where it is. The derivative of this is going to slide past the 4 and apply itself to the x squared, which is a 2x, and you're going to remultiply the 4, which makes it an 8x. Okay? Lee?
Fx, yes, f prime is this. It works for every number or only works for e?
Only e. There's a small variation if it's some of the base, which we'll see in later sections.
So once you prove the h, f plus h minus h over h, then every number should work.
You can.
Why is that?
Just right?
So you can start here?
Yeah.
Then
and use that function? Okay.
Can factor e8.
How do you think you factor the e to the a on the outside? Why is the e to the a able to come to the outside?
E8 plus h minus e8 is e8 is common.
Right? Like that?
Yeah.
How do you know you can take the outside the limit?
I didn't say that.
You're right, you didn't. I assumed as much. I want to do it, and no one can stop me. Why can no one stop me?
What is that anyways?
It's the definition. It's the derivative of e to the x. We're just using the limit definition. Lee wants to approach this from a more analytical perspective. So you can take the e to the a to the outside because only h is changing. So since a is not changing, it's a fixed value, and e is also a fixed value, so you're able to move that to the outside. So now you're stuck with this expression. So the problem is that this expression is unknown. Say again? Yeah. But to apply logarithms to a limit, we don't really know how that really works yet. No, I'm saying we haven't. We have not. So the idea is, what we do now is, first of all, we did not know what e was a second ago. I didn't know it was that number right there. Okay? So let's just claim that e is not known. We don't know exactly what it is. What we want to do is we want to find a function that does have this property, that it is its own derivative. That's important, to find a function like that. And we're going to believe it's an exponential function. It seems reasonable. So now the question is, what base should it be? So what we do is we pretend e is some base, I don't know what it is. And when you try to compute the derivative, you get to this expression, which I don't know how to compute this thing, right? It's a very difficult limit to establish. So what we do is we say, you know what? We're going to say this equals 1. This limit's 1. So what has to happen to make that true? E must be something special. So I'm going to tell you that e is the number that makes this 1. It's going to turn out to be that irrational number up there. So we force this to be 1, find out what e is, and now that is the base whose derivative is itself. It kind of works like that. Maybe not very satisfying, but that's the way it pans out. All right. So exponential base e, no big deal. It's itself.
I'm pretty sure that doesn't have to be.
Now let's see what they have for us.
That's the reason.
31. 31. F of x is x squared minus 1. It's my favorite function. X squared minus 1 over x minus 1. Find the derivative. Find f prime of x. Okay? Find f prime of x. So what you should first note is that we have not established how to deal with quotients. Yep.
Didn't you just expand out the numerator and then just simplify?
We factor it.
Yeah, factor it.
Okay, we can change this function's appearance a little bit to give us a good case. So x minus 1 over x plus 1 over x minus 1. So Justin says that cancels, we're left with x plus 1. All right?
Take the derivative of that.
All right, what's the derivative?
1.
Beautiful. Boom. Okay? So if you have a case, we have a quotient or a product of functions, which we have not talked about yet. And in this section, you're supposed to simplify them first, and then apply the derivative rules that we have so far. In 3.3, we're supposed to cover 3.3 tonight?
What?
3.3 tonight?
I just want to
Where's that?
I just want to learn.
Good man, Justin.
I just came here to get it over with.
That's good.
What?
I just came here to get it over with.
Oh, see some, man. Disappointed in
Don't worry. Just here to pass.
you. Oh, see some. Don't try to pass. Try to succeed.
Yeah.
Yeah. So we'll cover part of the question rules tonight as well. Alright.
So you're on number 14 and 15.
Alright, 35 is the most standard question to be asked in this course. That is, find the equation of the tangent line.
Yeah, 13 and 14.
So that goes beyond the slope itself. We find the entire equation of the tangent line. The equation.
Yeah.
Tangent line to f of x at x equals a. Alright. To number 35. Y equals negative 3x squared plus 2. And the location is at a equals 1. So if you want to find a tangent line, what does that imply? What do you have to find?
You have to find a line that grades this function.
That's right. That thing we found the slope of before, we want to find the whole line now. Okay? That line that's just glancing against the curve at 1. So we need to find slope first. Find the slope of that tangent line. First, is what it's really saying. And from there, you'll find the equation. Yeah.
Y, the A is representative of x, right? Y is representative of the function.
Oh. Yes, a is an x value. That's true.
So it's, we know it's at 1, and then we plug 1 into that. That'll give us a y.
Okay, so we have 1.